2-1, okay? On 2-1, we're just talking about plotting points, okay? Along that plotting point and then dictating a graph via plotting points, okay? So, if I had the points -2, 3, 3, 1, -4, -2, and 2, -6. I'd like you guys to plot those points using the Cartesian plane, which is just the xy axis. Okay? Take your time, just a minute. I'm going to push pause, let you guys do this, and we'll go over it because most of you guys should be. So, with that being said, remember, this is your x-axis, this is your y-axis, right? These represent your x values and your y values on the coordinate plane, correct? Are you giggling at me? You're supposed to go back to your homeroom, which is first period of the day, and go to that business. It would be chaos, let's just be honest. Okay, with that being said, here we go. -2, 3. Yeah. 3, 1. -4, -2, and 2, -6. Pretty self-explanatory, and we all should know how to do that since 3rd grade, right? Is everyone with me though? Feel good? Okay. Not too hard there. So now, the other parts that we're asking you to do is to graph things, okay? So let's start with something just basic. Can somebody tell me what that is, just because we know in the past what kind of equation that is? It's a linear equation, right? It's a line, isn't it? Okay, and I'm not going to graph it. We will when we get to 3-1, which is later in this one, but this unit, 2-1, we're graphing by plugging in points. Okay. Okay, so I like to do my Fab 5 a lot of the time. My Fab 5 are -2, -1, 0, 1, and 2. I like those points because notice it gives you some negative values, it gives you 0, and it gives you some positive values to work with, right? That makes sense to everyone? A little bit of X, a little bit of Y, that's what that chart represents. Okay, so if you'll notice here, I put in any X that I wanted. Could I plug in 100 if I wanted even? No. Could I plug in 1,000,000? Yes. Do I want to? No. Okay, there's a difference between want to and we could, right? But understand, sometimes I get a little frustrated with people when they're like, I don't know what the graph looks like. When in doubt, plug and chug, right? Plug values in, chug them out. So, -2, where is that going to be going? In for the X. So notice, once again, that's 3 times -2 minus 2, which is -6, minus 2, which is -8. Right? Everybody see what I did there? I plugged it in for X. Right? I guess I should have, oh, I did have a Y. All right. Then I plug in -1. 3 times -1 is -3 minus 2 is -5. This one's going to be -2. This one's going to be 1. And this one's going to be 4. All I did was, once again, plug them into my equation, didn't I? Right? Okay. Now we're going to go ahead and plot these values. So we're at -2. -1, -5, 1, 2, 3, 4, 5. -2, 1, 2, 4. Now, what's the definition of a line or any graph, basically? It's a combination of points so close together it looks like they're tough, isn't it? Do they really? have this line going through them? No. What it is notice, guys, we can have an infinite amount of values we can plug into this. Right? I can plug in a half if I wanted to. I can plug in a 16 or things like that. But usually I'm picking nice values and then we just connect the dots in between because once again, there's an infinite amount of points within any 2 points, isn't it? Okay? And then we connect it. Any questions there? Anything good? I'll just stare down. Okay, let's do another one. This might be a graph that you don't know what it looks like. Uh-oh. Guess what, Flo? My wife said we might be going to Charlotte today. I'm excited. I didn't know about that until like an hour ago. I wanted to tell you. Okay, this time, ladies and gentlemen, if you'll notice, who solved for it? X's. So where am I going to put my values into? I'm going to put them into Y. Whoever solved for it is usually the one you want to leave open, right? Because it's a little bit easier to go ahead and do your math on the one side, right? Does that make sense to everybody? Okay, I'm going to still do my Fab 5. Now, does the Fab 5 work every single time? No. Because we should kind of, there's some graphs that you can kind of know what's happening. Does anybody know what a x squared graph looks like? Say, parabola, which is kind of like a U shape. If you're not getting that U shape, you need to start plotting some more points so you can get it completely. Does that make sense what I'm saying? How about an absolute value graph? The V shape, isn't it? Does that make sense? So if you aren't quite getting the V, and you're just getting lines, then you probably need to plot some other points. Make sense what I'm trying to get at there? All right. Okay, but I'm going to pick these ones and we'll see what this looks like. Does anybody have an idea what this looks like before we even start? It's a sideways parabola. Okay, so here we go. Let's do -2 squared. 4 times 2, 8 minus 3, 5. Does everybody understand how I got 5? Oh, crappers. Sorry, guys. Sorry. I need to erase this, don't I? What did I do wrong there? Can somebody tell me? I put them on the X's, and what am I should have been putting those in? The Y. Sorry about that. Does everybody understand what I made a mistake there, though? Sometimes I just get in that habit, right? But once again, we did the same thing. Plugged it in for Y, and we got 5 for that value. Okay? Plug in -1. -1 squared, we get 1. 1 times 2 is 2. 2 minus 3 is -1. Plug in 0. 0 squared is 0. 0 times 2 is 0. 0 minus 3 is -3. This will be -1, and this will be 5. Any questions where I got those from? Okay, so what this graph looks like, 1, 2, 3, 4, 5, we're up to -1, we're at -1, -3, we're at 0. Oh, sorry. -1, I'm at 1. Okay. Any questions there? All right. Next item. Is that pretty good? Are we all clear with that section? It's not too hard, right? Pretty self-explanatory. You guys catch up to this. Those are pretty. Those are pretty. Yeah. I need to get you new shirts. I have access to them. I can. You sure?
Yeah.
All right. Okay, so, hold on. Let me make sure. Oh yeah, I need one more thing here. I apologize. Okay, what does an x-intercept mean? Do they know? Where the graph crosses the x-axis, right? Okay, that's a x-intercept. What's a y-intercept? When it crosses the y-axis. Let's talk a little bit about that though. So an x-intercept, so notice as you said here, it's anywhere I cross this axis, right? It could be anywhere on this line somewhere. That's on the line, by the way. Okay? Anywhere I cross that axis. Can somebody tell me something consistently on that axis? What's happening every time on that axis, no matter what? Y is 0. That's very important, right? For an x-intercept, we always know that y is 0. Okay, so we have a point where it could be whatever, we don't know, comma, but it's always going to be 0, isn't it? That makes sense for an x-intercept? Okay, what do we always know about a y-intercept? On a y-intercept, that's once again anytime we cross this axis, and that's always when x is 0, huh? You want to shut that here? If you don't, I'm okay. So that's 0, comma, something, right? Everybody there with me? So let's go back to our previous two examples, if you guys don't mind. Okay. So we had, was it y equals 3x minus 2, right? Okay. Let's go ahead and find our y-intercept. Once again, that's when x was 0, right? So what do? It's like plugging in a point, isn't it? And solving. Plugging 0 in for x. So I have y equals 3 times 0 minus 2, which is 0 minus 2, which is y equals 2. So our y-intercept would be negative 2. And on our chart, we already had that, didn't we? Right? Okay. But on our chart, did we have our x-intercept? That's when y was 0. Did we have one of those? We didn't. So let's go ahead and do that. So once again, let's find our x-intercept. Once again, that's when y is 0. That's just the basic equation we just solved last time, right? We did on our previous unit. We add the 2 over. Divide by 3. That would be my x-intercept. Let's kind of look up at our graph and see if that makes sense. Not perfect. Did I have 2/3? Is that where it was? Does that roughly look like 2/3? But it should have been 2/3, huh? Gosh, I'm a horrible person today. I really do know math, though. I promise. Does that just keep your hands warm, right? Okay, let's look at this guy. Do we already see something already up here? What do we see? One of our intercepts. One of our intercepts is already on our chart. What intercept's already on our chart? X-intercept, right? Notice it's right here. My graph's not perfect, but you get the idea that that's it. So our x-intercept's already right there. Because notice, y was 0, huh? What are we missing, though? We're missing our y-intercept. And notice from our graph, though, how many of those guys are we going to have? We're going to have 2 of those, aren't we? Okay? Because it's crossing it twice. Okay, let's figure that out. Remember, a y-intercept is when x is 0. So I plug 0 in for x. Now we haven't solved one of these, but we're going to have fun and just kind of go at it because you guys are smart people and I believe in you. Okay? So, same kind of thing here. We're going to add the 3 over. Now what? Divide the 2 over, right, first. How do I get rid of squares? Square root. But remember, does anybody remember when I square root what I need to do? Plus or minus. You guys remember that? Plus or minus, because remember, if I had x squared equaling 4, what 2 values of x, when I square them, will give me 4? Positive 2 and the negative 2, right? There's 2 solutions. When I square it, they can give me that result. Okay? All right. So I need to do plus or minus. I'm not trying to get too deep in this. Like, this is deeper than I probably want to do. But can anybody tell me why we don't like that? That would square with our denominator, huh? And if you guys recall, how we get rid of that is timesing square root top and bottom. Because what's square root of 2 times square root of 2? 2. And then square root of 4. Square root of 3 times square root of 2, square root of 6 over 2 plus or minus. That would be my y-intercept. So I have 0, comma, plus or minus root 6 over 2. How many ounces is that thing? 10? I bet I can drink one of those in one, like, breath. Maybe. Huh? Okay, good job. I don't know where my big guy is. I went home. Yeah, I don't know where I went. I lose crap. I have no other. But luckily, Mr. Garrison gave me that. All right. Any questions? We doing good? No, absolutely great. Because I do. All right. So we're going to do 2-2. Okay. Once again, a relation, we're going to do relations and functions. Relations and functions. Okay, here is a relationship. Okay, where this is my x values, this is my y values. It's basically saying, what does this represent, this line? How can I write this as a coordinate? My x is -3. My y value is 2. Does that make sense, everybody? Give me some other points. What's another one up there? Who does -4 go to? Still 2, right? Who does -5 go with? 3. Who does -6 go with? Okay, those are just points. That's a relationship, though. Okay? Now, as this relationship is there, is it a function? Anybody remember what the definition of function means? You should have learned that in the past as well. What do you got? Give it a shot. They're not for every output. Because look at this one. I have one input, but he's going to the same output, so that guy doesn't have it. So kind of a little bit, but for every input, there is exactly one output. So what does that mean? It means -3 can go to 2. -4 can go to 2 because they have their own output, meaning -4 is not going to 2 and to 1. Notice he has one input, he's getting one output, right? Okay, how can we check something if it's graphed to see whether it is a function? Okay, first off, let's write that down. Function. One input has only one output. One input has one output. Okay. So if we look at these two graphs that we just graphed, one looked like such, correct? And one looked like such. One of them is a function and one of them is not. If you recall, how can I tell whether they are a function or not? We can do the vertical line test. Notice if I go ahead and do it here, that's crossing 1. If I do it an infinite amount of times, how many times is it going to cross every single time I do that? Only once. Is that a function? Yes, because that red line represents one input, and how many times you cross your graph represents how many times or how many outputs that has. Okay? So with that being the case, a line, right, is a function. Okay? How about the sideways parabola? Is it a function? That one input, notice two outputs, he would not be a function. Correct? Awesome. Any questions on that? Okay. So, with that being said, so you have functions. What if it looks like this? Let's see. So what that means is that this line is working, but at this exact x value, we have a spot that works here, and it works there. Okay? So notice, though, if I do my vertical line test, it passes down here. Doesn't it? But what was the key thing? Did I put the word every, or is it just did I put one input for one output? It's every input. So does every single input have only one output? As soon as I went through that guy, notice two outputs, right? So that one place made it not a function. Okay? That was 2, 3 instead of 2, 2, I apologize. I wrote 2, 2, 2, 2. I wrote 2, 2. This is technically 2, 2, yeah. Sorry about that.
All of what we've done on this page.
Right.
Should have switched this to 2, 3.
Yeah, it's not. Okay. See it?
Almost, we're getting there. Just trying to see what you can do.
All right.
So we also have function notation.
X squared minus 6x, which is still 2x. Okay? If I asked you guys to graph this, how would I do so? What kind of graph should it be like, at least? Should be a parabola, a U-shape, right? Because it's an x squared. We've studied those in the past, right? Okay? So, I want you guys to tell me, though, what is f of 3? What does that mean? So is it for every x? It's just saying, I replaced x with 3. I guess it's kind of right what you're saying. I would go back and then change every x with a 3. It's a substitution type process, right? It's telling you that this point is 3 comma something, right? They're telling you it's the x value because that's being what's replaced. So therefore, I come into my equation, and anytime I see an x, I replaced it with a 3, didn't I? Okay? So what is this the same thing as? F of x is just another name for y, basically, isn't it? And the reason being is this is what we call an output. And x is an input. Doesn't our outputs always depend upon what our inputs are? Basically. One's called an independent variable, one's called an dependent variable. Does our money depend upon our time when we go to work, or does our time depend upon our money? So you get your time depending on your money. When we go to work, however much time we put in tells us how much money we'll get, right? So our cash flow is dependent on how many hours we're working, correct? Does that make sense? One's an independent variable. Time is just a relative thing, but in terms of working, our average salary or whatever we get for work is dependent upon the hours that we're working. Anytime you have an independent variable, it is the input. Anytime you have a dependent variable, that's your output. All right, let's finish this out to find our output for this designated input that we put in 3. 3 squared, 9 minus 18 is negative 9. Okay. Any questions on how to find using specific input? Once again, if I wanted to graph this, what would I need to do? We already plugged in 3 and we got negative 9, right? What else could I do? What are some other values? 2, let's try 2, okay? 2 squared is 4, right? Minus 6 times 2, which is negative 12, so 4 minus 12 is negative 8. Now, key quick thing, let's pick 1 just for kicks and giggles. One squared, 1, negative 6 times 1, negative 6, 1 minus 6 is -5. Are we getting lower? So guess what that's meaning? So because if you always think about a parabola, it's symmetrical, right? So therefore, so far this is what we have. 1's at -5, 2's at -8, 3's at -9. Let's pick 0 really quick. What do we get? 0. So if we look at this part of the graph, it's coming up. So it's like this part of the U, isn't it? So is that a complete part of our graph? Are we graphing everything? What else should we probably do? Graph some of the points on this side, right? Does that make sense what I'm trying to go for there? Okay. I'm going to scroll down just a little bit more again. Plug in 4. How about 4, 5, 6? We plug in 4. Can't remember the equation. What was the equation again? So if we plug in 4, that's 16. 6 times 4 is 24. 16 minus 24 is -8. Oh, that's kind of nice, because look, it's matched up. That means I'm coming back up again, am I not? Plug in 5. That's 25 minus 6 times 5 is 30. So 25 minus 30, which is -5. And if I plug 6 in, that's 6 squared, which is 36, minus 36, which is 0. Do we have the shape that we thought we should have? There we go.
Now, notice with my half size, whether the word is up.
No.
Make sense?
Sometimes you gotta pick around, jump around, figure out what you need to have. Okay? Any questions there? Awesome stuff. Yep. Yes, sir. Yep. This one, and the key goal is, I'll be honest, I'll give you for instance. Okay? There are certain calculators out there. Have you ever heard of the TI-89? Okay, it's one of the newer calculators. Really nice calculator. It does math for you. Like if you say solve for y, it'll do it. So when I was in college, there was that calculator around. And in calculus, I would ride derivatives and all these other things and try to see if you know what's going on. And it does it for you. The kid, our one calculus teacher lets you any calculator do. This is busted through it. They went to Calc 2, and we couldn't even use scientific. We had to use just the old school times, divide, multiply thing, right? That's all we had. And that kid just went, oh, gone. He couldn't do anything because he just relied on it. So I think the goal is just to make sure that you're doing the math that you're relying on it to do. You good? Stretches? All right. Any questions there? I think that's pretty much good on the 2-3. Anyone? All right. Awesome. Okay, 2-3. We're going to give you 3-1 now. This is linear equation. We're graphing linear equations. And I'm going to show you in 2 different ways how to do so. What's the most common way that you guys all know how to graph linear equations? What's the way you've always seen it? Y equals mx plus b, right? Isn't that most of the time how you guys always graph items, correct? What does the m stand for? Slope. And what does slope stand for? Rise over run. We're going to rise a certain amount, and we're going to run a certain amount. Right? B. What does B stand for? The y-intercept, where we cross the y-axis, right? There's another method, another form. So this is called slope-intercept. This one right here is called standard form. You guys catch up really quick. And we're going to graph those in two different ways. Okay? If I see it in slope-intercept, that's the traditional way you guys all done it. Okay? Standard form. If we're in here, we start at the y-intercept, we use our slope, pretty simple. If we're here, I'm going to have you guys find them via your intercept. That's the way we're going to go. Okay? And then we have a couple others just as well. All right, here we go. Let's start with y equals negative 4x plus 7. Negative 4x plus 7. I don't know what I'm doing wrong. I swear. I don't know. See, what the hell today? Okay. Here we go. Where do we start out here? We always want to start out at our y-intercept, right? 1, 2, 3, 4, 5, 6, 7. Okay? Now, we have a slope of a negative number. So right now, we kind of should have an idea of what that graph should look like. Slopes with positive numbers should be increasing, right? As you move left to right, correct? Slopes that have a negative number should be decreasing, meaning the higher they are from the right, they should be coming across as going negative. You guys agree with me? Okay. So we should have an idea that this graph is coming down like such, correct? Coming from negative infinity should be a lot higher. As we go to negative, positive infinity should be a lot lower, right? Okay. So get aware of that. Okay. So what's underneath here, even though he's not there, underneath the negative 4? A 1. It's still important to write that for the fact of the matter. Once again, then we can have our rise over run, correct? So I'm going to start right here at negative 7. Okay, I'm going to go down 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. What if I wanted to go up? Isn't negative 4 over 1 the same thing as 4 over a negative 1? So couldn't I go opposite? Instead of coming down and then going to the right one, I could go 1, 2, 3, 4 over a negative 1, right? Does that make sense what I did there? I just put the negative on the run instead of the rise this time. I would like you guys, if you wouldn't mind putting this down, that I would like a minimum of 3 points. A minimum of 3 points is what I would like on your graph for a linear equation. Minimum of 3 points.
Wish I had a straight edge, but I know. So here we go.
Good enough right there. Okay. Does it have everything we need? Does it have a y-intercept? Is it going the direction we hoped with a negative slope? Okay. All right. Ready for another one? Here we go. Let's do another reason why I like improper fractions more than decimals. What is 4/3 of a decimal? 1.32666. Isn't it hard to rise 1.33, run 1? Isn't it easier to rise 4, run 3? Another great reason why we use an improper fraction instead of decimals, right? Okay, where are we going to start out at? Now, where are we going to start? Which is? Mid. I didn't mean to call you out on that. -1. Notice it's already in rise over run, isn't it? The group, right? Sandler? Sander. That's pretty good, though. Give me a little bit. Here we go. 1, 2, 3, 4. How much are we running? 3. Maybe I don't want to rise and run anymore 4/3. What can I also do? I can go down 4, run a -3, couldn't I? Notice I have my 3 designated points. I can go ahead and graph that. Oh, shouldn't it? There we go. Please put arrows on them. Why do we need to put arrows on them? What does that mean when I do so? Keeps going because these are going on forever, right? All right, awesome. Nothing too hard. A lot of this is like, oh, why am I in this class so long sometimes? Okay? And if you are maybe saying this is a little difficult, that's fine. That's why maybe you're here as well. Okay, let's do this guy. This guy is in standard form. Could I solve for y like we did in the previous unit and then graph as y limit plus 2? Sure. But in my opinion, if it's ever in standard form, this is a really nice graph to just go by its intercept. I like to graph standard forms by my x-intercept and my y-intercept. Now I understand this isn't 3 points. How many points is that? 2. But with these 2 points, you get an accurate graph. Okay? So if it's in standard form, I'm only requiring you guys to have the 2 points. Okay? All right. But it's also nice because it's kind of using what we learned already in the previous 2 units. What is an x-intercept? When y is 0, right? So y is 0. So it looks like this point, correct? Something comma 0. You guys agree with that? So when I plug this in, I have 3x plus 4 times 0 equals 12. And the reason why I like this is, what's 4 times 0? It's just gone, isn't it? So basically, my x-intercepts, when I just basically cover him up, he's gone. Right? So therefore, 3x equals 12. So what does x equal? Y-intercept, what does that mean? When x is 0. So therefore, that's 0 comma something. I replace it. So y is 3. Pretty good with that. Okay. Those are my x and y intercepts. I'm sorry I'm boring you, but I'll be better. There we go. Pretty easy right there, right? There's only one case that I don't like when it's in standard form, and I'll show you what that guy looks like. Huh? No, she now works at SkyWest. She's back in the airline business. Why? Guess we're going to go to Charlotte today. Maybe. Hopefully we can get on. You'd want to go to Hawaii. We decide not. We're going to go there. 3-day weekend. That's the nice benefits of working in the airline stuff. You jump on and go. Happy day for you, huh? Just found that out. He's like, ah! The last summer hurrah kind of a deal, huh? Okay. All right, let's do one more of these standard, and then I got 2 more, and then we'll be done for the day, okay? So, really quickly. Oh, that's what I wanted to do. If I look at this really quickly, once again, this is a standard form. But if I find my x and y intercept, watch what happens. I'm going to find my x-intercept first. Okay, that's when, once again, when y is 0, right? You guys agree with me? Okay, so I have 3x. Negative 2 times 0 is 0. He's gone. Equals 0. Then what happens? I need to divide by 3. What's 0 divided by 3? 0. Isn't that my y-intercept at the same time? That's a slight dilemma, isn't it? Right? Because it's my x-intercept and my y-intercept. So I do know it's going through the origin. That's what we call that, the origin. But is that enough points to go ahead and graph it? No. So what do I need to do if it's ever this case where if my x and y-intercept are both the same, I do need to go ahead and solve for y. Okay? So I'm going to go ahead and add the 2y over. So I have 3x equals 2y. Do we want x to be by himself, or do we want y to be by himself? Y. So I'm going to divide by the 2. So y equals 3/2 x. Right? So what are we going to do now? We already have our y-intercept. So I'm just going to rise 3, run 2. Or I could go down 3, run a negative 3. But do you see how that's a slight dilemma if I'm trying to graph by my intercepts and they're the same thing? The origin, you need to go ahead and then get the slope going. Okay? Question? Are we good to move? Y equals 4. Is that in y equals mx plus b? It is. What's our slope? 0. We're not rising at all, are we? Are we running? We are. So, understand, this is how I had to think about this. Because when I was young, I used to get these mixed up all the time. So what I had to finally say to myself, what if I put x is 2, what's my y value? 4. If x is 4, what's my y value? 4. If x is 1,000,000, what's my y value? 4. It's always going to be 4. So notice here is when y is 4, right there, right? And right there, and right there, and right there, and right there. All the time, that's where it's going to be. So it's a horizontal graph. Okay, because no matter what your x value is, your y value is always going to be 4. Now, ladies and gentlemen, what kind of slope is this? What slope did we have? This is a slope of 0. Notice because we're not rising, 0 rise, but we are running. 0 divided by any number is 0, right? Okay? Is everybody there with me on that? But then we have the other type, which is like x equals -2. What is that saying? No matter what my y value is, what's x always going to be? So what is it going to be? A vertical line. Because your x value is always going to be -2. Right? What kind of slope does he have? How much is he rising? He is rising, isn't he? We could say rising 1, we could say rising 1,000,000 if we wanted, right? He is rising some number. How much is he running? He's not running at all, is he? That's 0. What's a number divided by 0? Not 0. Undefined. Remember, dividing by 0 cannot happen. Do you guys know why it can't happen? Really, it took me like 5 years ago until I really understood. Until then, it was just like, I can't do it because somebody told me. Right? I'm going to show you really quick, just so you guys get an understanding of why. Okay? So if I had 0 divided by 4, let's go back to old school division. Okay? How would I write this in old school division? I'd go 4, divisor bar, 0, right? And when we do division, we say what? 4 times what number gets me this result, right? 4 times what gives me 0? 0. Hence why this is 0. Right? Everybody with me on that? But what is 4 divided by 0? Okay, so that's 0 on the outside, 4 into here. 0 times what gets me to be 4? It won't ever happen. There's nothing ever to get close to 4 when it's times by 0, right? 0 times nothing will ever get me close to 4. So hence why the undefined. Zero group, exactly. Does that give you a better reasoning why we can't divide by 0? Because sometimes I think we just do math because somebody's told us to do math instead of understanding why it's that way. Does that make a little bit more sense? All right. So I don't have you guys a worksheet yet to tell you what's homework problems. So I'm going to go ahead and just assign them today. Here we go. So I am going to write it on here for those people. So 2-1. Let's do, how about just the odds on that one? That looks good if we do the odds. I like that. Not too many, 8 problems there. Two dash 3. $39. $42 is an interesting one that's going to make you think a little bit. 45, 47, 50, 53, 56, 58. Three dash 1. That's not many. Let's just do the odds again. That's just 6 problems. 3 dash 1. It kind of got cut off on the top. I apologize. All right. Now, once again, guys, so you guys can keep these for study practices, remember, please do your homework where? On a separate sheet. It will be next time. It will be due in class. Because remember last time I didn't give direction very well, so I didn't want everybody else putting their work, right? So it will be due in class next time. Unlike what we did last unit, for the fact of the matter, I want to make sure that I can get it this time on a separate sheet of paper, okay? I want everything on it, so don't even put any, I mean, you could, but everything you have right there. Everybody good? Yes, no? Okay, awesome, guys.